See here, according to law of radioactive decay, it says that the number of nuclei undergoing the decay per unit time is proportional to the total number of nuclei in the sample. Means it depends upon the initial number of atoms or initial number of nuclei present in the initial state, the initial number of in the sample. N2 is after remaining after certain time t. Means these radioactive elements what they do is they are giving out alpha, beta, gamma particles. Continuous reactions are taking place in the nucleus, and they are giving alpha, beta, gamma particles, and they reduce in their number of nucleus, as well as the mass also will come down. But it takes time because it depends upon the half-life period again. It depends upon the half-life period. But there are some nucleus which will take maybe hours. There are some elements atoms which will take millions of years also. It depends. It is changing from one element to another element, or one radioactive element to another radioactive element. So we have delta n is equal to L1 n1 minus n2. So delta n is the difference between the initial and final number of nucleus. So delta n by delta t is directly proportional to n. It depends upon the initial number of atoms or initial number of nuclei. So to remove the proportionality constant, we are writing lambda. What is lambda? Lambda is said to be disintegration constant. So if delta t is tends to 0, means if you are applying limit, then what will happen? Delta dn is equal to minus delta n by minus delta n, because it is decreasing. If it was increasing, we write positive. If it is decreasing, we are writing negative. So dn by dt is equal to minus lambda n. Cross multiply and apply integration. Cross multiply and apply integration means like terms together. So this is variable separable method. Dn by dt, and here minus lambda dt. Lambda is constant, so we remove it outside. This is initial to final. Initial to final. We also can write n0. Initial we can write as n0. If you are not able to understand, in some books it is written as n0, in some books it is written as n1, and in some books it is written as only n. So don't get confused with that. This is the initial and this is the final. For final they wrote like this, capital N. Initial n0, final n. Or we can write n1, n2. It's up to you, no problem. So t0 is the initial time and t is the final time. Now going to the next one, continuing with the concept. So here we have that is applying integration. So you know one integration of 1 by x dx is log x. Integration of 1 by x is log x. So the same way it will become what? Ln will become ln log c. In the textbook we wrote ln. Ln means what? Log to the base e. This is said to be Napier logarithms. Napier logarithms or natural logarithms. Napier logarithms or natural logarithms. And this is log to the base 10 is said to be common logarithm. Common logs. And there is a relation between Napier and common log. That is log to the base e is how much? 2.71 into log to the base 10. So this is how we can convert log to the base e to log to the base 10. Now, when we do this, when you apply here, it will become log ln n. From where to where? Lower limit is n0, upper limit is capital N, which is equal to minus lambda. This will become t. Integration of dt is t0 to t. So upper limit minus lower limit implies ln n minus ln n0 equal to log n log n0. Upper limit minus lower limit minus that is lambda into t minus t0. Minus lambda t minus t0. The difference is generally we are starting with t0 equal to 0 seconds. So automatically it will become what? We have one more formula. Log a minus log b. Log a minus log b equal to log a by b. So we are applying the same formula here. We are applying the same formula. When you apply this formula, what do we get here? We apply the same formula. Then we get log a minus log b is equal to log a by b. So we get here ln n by n0, which is equal to minus lambda t. Minus lambda t. So when we remove this, when we remove log here, it will become n by n0 equal to e to the power of minus lambda t. E to the power of minus, converting log to exponential. Now cross multiply this, n is equal to what? n0 e to the power of minus lambda t. Minus lambda t. So therefore, so this is the formula. Means number of nuclei present after instant time t is equal to how much? After certain time t. After certain time t is given by n is equal to n0 e to the power of minus lambda. This is the formula what we got. Next one is I want to find out what is half-life. I want to find out what is half-life. means half-life, the definition, oh, okay. This is number of atoms. If I want to find out the rate, okay, the total decay rate, if I want to find out the rate at which the rate, or we can say decay rate, at what rate the, you know, the nucleus will decay. The decay rate is given by what? The decay rate is what? R is equal to minus dN by dt. So the initial, so we can write here R equal to R naught into e to the power of minus lambda t, or R is equal to what? R is equal to, we get lambda into n0 e to the power of minus lambda t, which also can be written as R equal to R naught into e to the power of minus lambda t. Okay, R equal to R naught into e to the power of minus lambda t. Here, yes. So we'll go to the next one. So R naught here, R naught is equal to what? R naught equal to lambda n0. R naught equal to lambda n0. Now, and R is equal to what? R equal to lambda n. R equal to lambda n. So that is how it is. So there is a rate. Okay. That's a decay rate. Is it clear? Once again, see quickly. We are applying integration of 1 by x will become log x. Then after that we have two types of logarithms. One is log to the base e, one is log to the base 10. Log to the base e is known as Napier logarithms or natural logarithms. Log to the base 10 are known as common logarithms. There is a way to convert exponential logs or natural logs to common logarithm. Just multiply 2.71. Then when we apply here, when we apply log n, that is, this is lower limit and upper limit. Then upper limit minus lower limit, upper limit minus lower limit. Then log a minus log b will become log a by b. That can be written as n by n0, which is equal to minus lambda b. Just remove that log, it will become exponential, e to the power of minus lambda b. So that will become what? N equal to n0 e to the power of minus lambda t. So this is the final formula. Now I want to find out again the decay rate. At what rate the nucleus is decomposing. Generally, when we keep a dead body in the graveyard, then what will happen? Maybe after a few months or a few years, it starts decomposing. After certain, but there is a rate at which it starts decomposing. But when it becomes skeleton, it will take a long time to decompose. So that means what? The flesh decomposes faster when compared to the bones. That we got an idea. So at what rate it is decomposing? So R equal to what? Minus dN by dt. So with that we can write again here lambda into n0 e to the power of lambda t. So we can write here R is equal to R naught e to the power of minus lambda t. Clear? So next, quickly we'll go to the next one more thing. Here how to find out the half-life rate, which is very, very important. Okay. Here lambda is measured in activity. Before going to that, we have activity also in half-life rate. Half-life period is what? The time taken to decompose half of the initial mass. Okay, how much time it is taking to decompose half of the initial mass?
Why do they calculate half-life when they calculate the full life?
No, half-life means half-life. This is there in chemistry also. Half-life, T half P, right? Half-life means time taken by the radioactive nuclei to decompose half of the initial mass. So that is said to be half-life. So when you see here the half-life, suppose means what? N is equal to what? N0 by initial number was n0, and the final number is what? N, which is equal to what? N0 by 2. Substitute in the formula. What is that? N equal to N0 e to the power of minus lambda t. Here T is what? T is equal to T half of the initial mass. Let's suppose initially it was 1 gram. Initially it was 1 gram. So how much time it is taking to convert half of the gram? Okay, so that is what? Now it will become N0 by 2, which is equal to what? N0 e to the power of minus lambda T half. Okay, so N0 will get cancelled. The answer is what? 1 by 2 e to the power of minus lambda T half. Okay, minus lambda T half. So in this case, what it will become now? It will become T half is equal to log ln 2 divided by lambda. So ln 2 is equal to 0.693 by lambda. Actually, log 2 value to the base 10 is 0.3010. 3010. Log 1 value to the base 10 is equal to log 1 is 0. Log 2 is 0.3010. Just multiply with 2.71, you will get 0.693 by lambda. This is T half value. Okay, this is T half value. Understood? So, T half. Okay. So, that is T half is ln by 2. This is the formula for to calculate the T half. Now, how it works? How the half life works? Let me explain that now. So, suppose you have 1 gram of a nucleus. 1 gram. See here. 1 gram will become half gram in T half. Again, half gram will not become again half. Half of that will become 1 by 4 gram. That is again T half. Again, it will become 1 by 8 gram again after T half. Understood? See here, like example, there is 1 gram, it is becoming half of the gram after T half. Again, half of this is 1 by 4. Again, half of this is 1 by 16. Okay. Again, half of this is how much? 1 by 32 grams. So it goes in exponential path. Understood now? Like the curve. I just explained that. Is it clear? Just take a screenshot. We'll go ahead. Take a screenshot. We'll go to the next one. Now, so how to find out if a graph is given? If a graph is given, how to find out the T half from the particular graph? We'll do that experiment now. Suppose there is a graph like this. There is a graph like this. This is what time? This is number of undecayed nucleus. Number of undecayed nucleus.
So nucleus and nucleons.
Nuclei. Yeah. Plural form of nucleus, nuclei.
It's a nucleons.
Nucleons means protons and neutrons. This is about the nucleus.
Nucleus.
Atoms. Instead of saying atoms, we are saying nuclei. Now, it is what N0. It started from N0. How much time it is taking? See here. Maybe here it is N0 by 2. Here it is N0 by 4. Here it is N0 by 8. N0 by 16. See here what we are doing. Suppose if it is T half, one more T half, 2 T halves, 3 T halves, 4 T halves. The number of remaining is how much now? See here. Half of this. Maybe if it is 100, it is 50. It is 25. It is 12.5. It is 6.5. Understood? See here. 100, 50, 25 is here. Then suppose if it is 100, started with 100, this will become 50, this will become 25, 12.5, approximately 30. This is 6.25. Understood now? That is how. So that is the reason we can find out the half-life period using the graph also. If a graph is given, you can find out the half-life. Sometimes he will give in millions years. Sometimes he will give in this thing. You should focus here. Sometimes he will give in seconds. Sometimes minutes, hours, years. So you have to find. Be careful. Just don't write like that. So how many years? So they will give answer marks for that time also. So that is very, very important here. From the graph, you have to find out all those things. Okay. Now, so now last part is about nuclear energy. Nuclear energy, that is classification I have to explain. Nuclear energy classification. Okay. So nuclear energy classification is how it is. So here nuclear energy. Okay, it is not like a chemical energy. Nuclear energy classification. So nuclear reactions. To understand this, you have in nuclear reactions. You have two types of reactions. One is fission and fusion. Nuclear fission and nuclear fusion. Fission means breaking of a heavy nucleus into small intermediate nucleus, and fusion means combining small nucleus to form a bigger nucleus. Now, fission is what?
breaking nuclei.
So now, so here fission means what? It is splitting of a or breaking of a heavy nucleus into small intermediate nucleus so that it can emit enormous amount of energy is liberated. Now here we have controlled nuclear reactions, controlled nuclear fission and uncontrolled nuclear fission. Okay, controlled is what? Controlled is example for controlled is nuclear reactor. Nuclear reactor is the best example for controlled, and example for uncontrolled is atom bomb. Okay, atom bomb. And next example here for fusion example is what? Sun and stars. Sun and stars are the best example for this. This is the classification of the nucleus or nuclear reactions. Now, next one. Here, what happens in nuclear fission? See, there is a experiment here or a reaction here in fission. In fission, there is a nuclear reaction. What is that? That is when a slow-moving neutron goes and hits uranium-92 235, which is very highly unstable or reactive. Becomes highly unstable nucleus 36, uranium-92 236, which is highly unstable. So it splits into barium and krypton. Barium 56 144 plus krypton 56 89 plus 3 neutrons plus enormous amount of energy Q. So Q is equal to approximately 200 MeV. This much of energy is liberated. Once again, when a slow-moving neutron goes and hits uranium-92 235, which is highly reactive, it becomes highly unstable nucleus. Uranium-92 236, that will split into barium and krypton and 3 neutrons, and enormous amount of energy is liberated. Again, these three neutrons in a chain reaction, what will happen? In a chain reaction, N01, it goes and hit uranium-92 235. On an average, 3 neutrons are liberated. And again, this is the byproduct, that is barium and krypton. Again, these 3 neutrons will go and hit the 3 nucleus. Again, it will spread into 3 like this. See, this is a chain reaction. So it will be like 1, 1, 3, 9, 27, 81, 243, keeps on going. So it happens in a very short interval of time. So we have to control it. In nuclear reactor, what we are doing is, whenever these 3 are coming, no, we stop these 2. And again only 3. Again we stop these 2 from reacting, these 2 neutrons from reacting with the another nucleus. So that is how that is said to be controlled nuclear. Understood? So that is how. So this controlled chain reaction is used to harness the electrical energy in a controlled manner. So 90% of electricity in France comes from nuclear reactor only. 90%. So most of the countries are going for the nuclear. So it is safe also, but to be monitored effectively. It's to be, otherwise there were 2 nuclear reactions explosions taken place. One in Chernobyl, Russia, and the other one is California, Ukraine. Yeah, earlier that was USSR. Okay. Yeah. So that is why people are a little scared of that. Okay. No. So that is about in nuclear. What happens in nuclear reactor? Last part of this one. We'll see that what happens in fusion. Hydrogens combine to form a bigger nucleus. That is hydrogens combine here to form a bigger nucleus. So, anyways, we are going to the next one. That is nuclear reactor. There are 4 parts in nuclear reactor. What are they? Number one, fuel rods. Number 2, moderators. Number 3, control rods. Number 4 is coolant. See, what are fuel rods? Generally uranium, plutonium, these are the fuel rods. Moderators means they are fuel actually. They are basically fuel for the reactor. Moderators which see every time we are getting 3, we don't want those 3. We only want one neutron to go and react with uranium. So moderators, what they are doing, generally we have graphite rods. So it is to stop 2 neutrons. Here, control rods to stop the reaction. We want to stop the reaction, nuclear reaction. So what we do, we use control rods. That is what? Cadmium rods. Cadmium rods are the best example. and coolants are what? D2O, heavy water we use. So it is very hot. Okay, we use heavy water for this to cool down the, or sea water. We can also use sea water to stop this one. Is it clear? So that's the thing. So all of you, yeah, just go through that one. If you have any doubts, just ask me. Okay. Yeah. Thank you. We'll meet tomorrow.